Okay, let's take a look at this problem. We want to find the first derivative. Derivative of 8x is 8 minus 10. Extra power, take your power, put it out in front, lower it by 1. Gives us 8 minus 10 times 4 is 40, divided by 5 is 8. X, 4/5 minus 1 is negative 1/5. So we got 8 minus 8. Now take the x to negative 1/5 down to the denominator. It becomes x to the 1/5. Now I want to get a common denominator. So I need to have a denominator. So put 8 over 1 minus 8 over x to the 1/5. Multiply top and bottom by x to the 1/5. And I get 8x to the 1/5 over x to the 1/5 minus 8 over x to the 1/5. That gives us 8x to the 1/5 minus 8 over x to the 1/5, since they have the same denominator. And I could factor an 8 out of the top, but I'll do that in the next step. Okay, so now I'm going to set the top equal to 0 to find my critical values. And I'll set the bottom equal to 0. So here I'll take the negative 8 over to the right side, becomes a positive 8. Divide both sides by 8, and we get x to the 1/5 is equal to 1. Take both sides to the 5th power, and we're going to get x is equal to 1. Now here I can just simply drop the 1/5, and we got x equals 0. So we got our critical values here. Clear over here is negative infinity, clear over here is positive infinity. I want to choose test cases. Something between negative infinity and 0, like negative 1. Something between 0 and 1, like 1/2 or 0.5. Something greater than 1, like 2. We want to plug those into our derivative. I'll plug them in probably here. Probably the easiest. Now if I do use a calculator for this, if I go to y equals clear, put parentheses around top, and I got 8x caret, and then beginning parentheses 1 divided by 5, closing parentheses, minus 8, closing parentheses for the top part, divided by, beginning parentheses for the bottom, x caret, beginning parentheses 1 divided by 5, and you can put closing parentheses at the very end if you want. Now if I go to my table setup, I do second window. I want the independent to say ask, so I down arrow to here and right arrow, put flashing cursor on ask, and press enter one time, assuming your calculator is already set up for that. Now I go to second table, and I can plug in my test cases, and it'll evaluate them for me. So negative 1, 0.5, and 2. So I got a positive 16, so that's increasing. This is a negative, so it's decreasing. And this next interval is positive, so it's increasing. So, and you could write those out if that's what the question is asking for the increasing and decreasing. This is increasing from negative infinity to 0, decreasing from 0 to 1, and increasing from 1 to positive infinity. Since it's increasing here and then decreasing, this will be a max. And since this is decreasing and then increasing, this is going to be a min. So I'll have 0, comma, and you want to plug this back in your original function. Put 0 here, 8 times 0 is 0. Put 0 here. 0 to the 4/5 power is 0 times 10 is 0, so I'd give us max is 0, 0. Min, 1. If I put 1 in here, 8 times 1 is 8. 1 to the 4/5 power is 1, times 10 is 10, so I got 8 minus 10, which is negative 2. And those would be our relative min and relative max. Now I need to find my second derivative. And it's best to work with this one before you start simplifying, so this is what I'm going to continue with. So our second derivative, the derivative of 8 drops away. Then I got negative 8. Take your power, put it out in front. So put negative 1/5 out in front. X, lower your power by 1. Negative times negative gives us a positive 8/5. X to the negative 4/5. Now I'm going to take that x and negative 4/5 down below. It becomes x to the positive 4/5. Now I set top equal to 0, set the bottom equal to 0. 8 equals 0 doesn't go anywhere because there's no variable. Here I'll divide both sides by 5, and a 5 will drop away. And if you have a power, and you got 0 on here, you can just drop power too. So we get x equals 0. Now here's my negative infinity, here's my positive infinity. I want to choose test cases, something between negative infinity and 0, like negative 1. Something greater than 0, like 1. And I want to plug those into my my second derivative right here. And again, you could use a calculator for that. So we got go back to y equals clear 8 divided by, parentheses are on the bottom, 5x caret 5x caret beginning parentheses 4 divided by 5. Go to my table and delete those. Then I'll put in negative 1 my test cases and positive 1. Both of these come up as positive. Since there is no change in the concavity, that means there is no POI, no point of inflection. I wonder what this graph looks like. Let's see. We got 8x minus 10x caret, beginning parentheses 4 divided by 5, closing parentheses, and then graph. Increasing, hits this point here, then it's decreasing, and then hits this point and changes to increasing. Okay, max is 0, 0. I could buy that. Min is 1, negative 2. I could buy that. I can't really see the concavity from it, but that would be your graph.